Hi everyone, this is your 5.5 Ready, Set, Go notes. So you should be on page 13 in your yellow packet. So make sure you've got that so you can follow along while we take these notes. So we have one learning target for today, which is 3B.5.2, and we've actually already started working with this learning target. It's I can solve a system of equations using algebraic methods, including substitution and elimination. So we've already covered substitution, and in fact, you just took a formative assessment on it. So now we are going to start talking about what is elimination and how do we solve systems using elimination. So here we've got some steps for us to follow, and we've got an example that we're going to kind of do alongside it. So the first thing that we have to do is arrange the equations so that like terms are in columns, or that they're vertical. So what I mean there is if we look at these two equations, we can see that the x's come first in both of our equations. And then we have the y's, and then the equal signs, and then they equal the constants there. So they're lined up in like terms. X's are on top of x's, y's on top of y's, numbers on top of numbers. So that's what we mean by the first step there. Arrange the equations so they're in like terms. So we can see that that's clearly what's going on there. The second step is to multiply one or both equations, if necessary, to create additive inverses. For one of the variables. So we're going to talk about what it means to be additive inverses, but really in general here, what we're looking for is we're looking for numbers that will cancel each other. For one of the variables. So we know that this word inverse means the opposite, right? When we're solving equations, we use inverse operations. We undo what's happening. So additive inverses just mean that they're the opposites of each other. So for example, if we had in one of our equations a negative 2x, then the additive inverse there would be what number do we need to add to it in order to get 0? And in this case, the additive inverse would be plus 2x, because when we add those two things together, they cancel each other out and they become a 0. If we wanted to look at another example of additive inverses, let's say we had something like 13y. The additive inverse would be the opposite of that, which would be negative 13y. And again, the reason those are additive inverses is because when we add those together, they cancel each other out and they become 0. So we're going to be looking at these equations and try to figure out, do we have additive inverses? And if we don't, we need to pick a number to multiply by so that we can create those additive inverses. So if we take a look at our example here, hopefully you can see the x's, we've got negative 1x and negative 3x. And for the y's, we have negative 2y and positive 2y. Those are already additive inverses for us. So what that means is we don't have to multiply this equation by anything in order to create those additive inverses. So we actually luck out that step 2 really doesn't matter in this problem. So let's talk about what comes next then. In step 3, we are going to have to add the two equations together and then solve for the remaining variable. So let's see what that means. If we take our two equations here and we decide to add them together, then I'm going to draw a big equal sign here, and I'm going to add the x's, add the y's, and add the constants. So if I do that, I have this negative x plus negative 3x. So just in case we need to, we can pull up our calculator here, and we can do negative 1 plus negative 3. and we get -4. Now, some of you might already look at that and go, oh, it's just -1 minus 3. And that's okay, but for the purpose of talking about additive inverses, I just wanted to show that. So, and also I kind of jumped ahead there. There's that -1 there. But we get -4x. When we do -2y plus 2y, those cancel each other out. Those were the additive inverses that we were looking for. So they're just going to be gone. And we get -12 plus -12. And again, let's pull up our calculator just in case. -12 plus -12, and we get -24. Well, now if we look at this, by adding these two equations together, we made the y go away. We eliminated it, right? It's gone now. So what that means is now there's only one variable here, and I can solve for it. When I look at this, it says -4x equals -2. So all I have to do to get the x by itself then is use my inverse operations, and I'm going to divide by -4. I get x is equal to +6. And that means I've found half of my answer already. I was able to get rid of the y, or eliminate it, and I was able to solve for x. Now I have to think about how to move forward from here. I know that in order for me to have a solution to a system, it needs to be an x and a y. So let's take a look at what step 4 is. Step 4 says, using your answer from step 3, substitute into one of your original equations to solve for the remaining variable. So in this case, we're going to take the x value that we found, and we are going to plug it into one of our equations. So I'm going to take the first equation that's there, which is -x minus 2y equals -12. Now, it doesn't matter which equation you pick. You can substitute into either one. So let's go ahead and take that 6 that's there, and we're going to plug it in for x. So -x minus 2y is equal to -12. And we know we're going to plug in the 6 that's there. So really, we've got -6 minus 2y is equal to -12. And now when we look at this equation, there's only a y, so we can actually solve this. So we're going to use our inverse operations. We're going to add 6 to both sides. We get -2y is equal to -6. And then we're going to divide both sides by -2. And we get y is equal to +3. So now when we look, we can see there's an x and there's a y. So hopefully you can already guess what step 5 is. Step 5 is to write your answer as an ordered pair, because we know we can't just say x equals this and y equals that. So we're going to go ahead and actually write out solution. And in this case, we know our solution is 6, 3. And then remember, the last step anytime we solve a system is going to be to check our solution by substituting. So just like we did when we used substitution for solving, we are going to have to use substitution to check our solution here. So let's go ahead and do our check 1. And again, we're just going to write our equation. So -x minus 2y equals -12. And we're going to take out the x and the y and substitute in the values that we have found. So I've got parentheses there, and I'm going to put in a 6 for my x and a 3 for my y. And let's just check to see if this is true. So -6 minus, let's see, 2 times 3 is 6, equals -12. -6 minus 6 is in fact -12. So we get -12 is equal to -12, and we know that it works in that first equation. But remember, just because it works in one equation does not mean that it's the solution to the system. We have to check it in both of our equations. So we are going to have to check the other one as well. So our second equation is, let's see, negative 3x plus 2y equals negative 12. So again, we're going to take out the x and take out the y and substitute in the values that we found. So we found 6 for our x value and 3 for our y value. And let's check to see if this is true. Negative 3 times 6 is negative 18. 2 times 3 is 6. Negative 18 plus 6 is in fact negative 12. So we get negative 12 is equal to negative 12. So there is this check for the other equation, which means our solution is in fact 6, 3. We are good to go. Now I know that that's a lot of steps, so we are going to do another example together before I let you go. So now we're at the top of page 14 here, and we're going to do this first example problem. The directions tell us solve the following linear system using elimination. So like I said earlier, to eliminate means to get rid of. So we are going to be looking to get rid of one of the variables so that we can solve for the other. Let's take a look at what step 1 was. Step 1 was to arrange the equations so that like terms are in the columns. So when we take a look at this, we can see that the x's are lined up on top of each other, the y's are lined up on top of each other, and then it's equals, and then we have our constants. So we know that step 1 is taken care of for us. They're already lined up. Step 2 is to look for additive inverses. So remember, we're looking for numbers that when we add them together, they will cancel. So I always like to take a look and see what I have available to me. I have a 7x and I have a 5x. I know if I add those together, they will definitely not cancel, and they're not really easily turned into one another either. So let's take a look at what comes next. Next, we have a positive 2y and another positive 2y. Now, if I add those together as of right now, I get a positive 4. But if I could make one of those y's actually be negative 2y instead, then they would be additive inverses. So this is where that multiplying part comes into play. So what I'm going to do is I am going to multiply my first equation here by a negative 1. And the reason I choose to do that is because, like I said, I have a positive 2y and another positive 2y. If I could make one of them negative, they would be additive inverses. So to make it a negative 2, all I have to do is multiply the equation by a negative 1. I'm going to take this negative 1 and distribute it inside. So I'm going to get a negative 7x. Negative 1 times positive 2y is a negative 2y. And then negative 1 times positive 25 is a negative 25. Now I know that it looks weird because I put the entire equation in parentheses, and usually we will just do one side, but we need to multiply this entire equation by that negative 1, so every single piece gets it. And then my second equation, I'm actually not going to change it at all. I'm just going to rewrite it. So I have 5x plus 2y is equal to 21. I didn't change anything about it. But now when I look at my equation, I can clearly see here are my additive inverses. And when I add those together, they will cancel each other. So I'm going to go to step 3 then, and I'm going to actually add these equations together. So I'm going to add my x's, I'm going to add my y's, and I'm going to add my numbers. Negative 7x plus 5x is going to give me negative 2x. Negative 2y plus positive 2y gives me 0. Those cancel out or eliminate each other. That was the whole point of doing this. So they are gone. Negative 25 plus 21 is going to give me negative 4. Now this is an equation that we just know how to solve, right? This is a one-step equation. We can use our inverse operations and divide by negative 2. We get x is equal to a positive 2. Now we need to go back and we need to solve for the other variable. So in this case, we still need to solve for y. Well, I'm going to take one of my equations. So I'm going to take the 7x plus 2y equals 25. You'll notice I took one of the original equations, and I'm going to substitute in the x that I found. So I'm going to do 7 times 2 plus 2y equals 25. Right, inside those parentheses, I'm going to put the x value that I found. So I get 7 times 2 is 14 plus 2y equals 25. And now I can solve. So I'm going to subtract 14 from both sides. I get 2y is equal to 11. And then I need to divide both sides by 2. We get y is equal to 5.5. Now don't freak out just because it's a decimal. Sometimes we get decimal answers and that's okay. You can always feel free to ask if you want me to check through some work, but sometimes we do get decimals. So that was another reason I wanted to make sure that we do this problem together in the video. But now if we look, we have our x and we have our y. So we know the next thing we have to do is check our solution. And actually we should write it as an ordered pair. Sorry about that. So it's 2 comma 5.5. 2 is our x and 5.5 is our y. So now we can go ahead and do our checks, just like we did before. So check 1. I'm going to take my original equation, which is 7x plus 2y equals 25, and I'm going to plug in the numbers that I found. So 7x plus 2y equals 25. I want to know if that's true. I'm going to plug in 2 for my x and 5.5 for my y. 7 times 2 is 14. 2 times 5.5 is 11. 14 plus 11 is in fact 25, so we get 25 is equal to 25. Now, since that's the equation that we used to solve for y, it probably would work out. Now we need to check our other equation though. So our second equation was 5x plus 2y equals 21. We're going to take out the x and the y and substitute in the values that we have. So we said the x is 2 and the y value is 5.5. 5 times 2 is 11. No, 5 times 2 is 10. Sorry about that. 2 times 5.5, however, is 11. And we know that 10 plus 11 is 21. And remember, you've got your calculator app on your Chromebook, so you should be, in fact, double checking and making sure that I'm doing all of my arithmetic correctly, because we know I'm human, I make mistakes. So please make sure you're doing that and you're getting comfortable using your calculator anyway. But this is our work then for our second check, so we know that that is the correct solution. Now, you all left class after your formative to watch this video. You need to make sure that you return to class at whatever time I specified for you. So 5th and 8th periods are going to be coming back at different times. So please make sure that you know what time you are expected to be back in class. And if you have questions, you can send me a GChat or a text on Remind or an email, but make sure you come back to class when you are expected to be there. And if you've got any questions, make sure you've got them written down so that we can go over them when I see you back in just a little bit. Thanks for watching.